Hello, my name is Matt Jordan. I'm a Senior Software Development Manager at Amazon S3 Glacier, and it's my pleasure today to be able to share with you best practices for archiving large data sets with AWS. Now, there's lots of reasons why a company may want to archive large data sets. To illustrate some of these, I'd like you to imagine a company, purely hypothetical of course, who over time found themselves having to manage a large amount of archival data for a variety of reasons. Now, this company had started off, like so many do, as a small startup. And over time, their data, and the reasons for having it, grew with the size of their company. At first, they had a need to retain their records, sales, order processing, and more. And so they had a small local data center that they contracted with. In that data center, they had a few racks running some local databases. Maybe they also had a network-attached storage, which became something of a document store for marketing, sales, finance, and engineering. And while the company started off with some relatively straightforward data sets, over time, the types of data stored became a little bit of a hodgepodge. Maybe everything from business data to code artifacts, office documents, and even hardware schematics. However, this data, maybe what we'd call a data lake, contained a lot of the company's crown jewels, things that made the company unique and competitive. And so the CEO justifiably became concerned with the integrity and retention of the data. As the company became more sophisticated, they entered new verticals, and so naturally the CEO becomes more concerned with complying with various rules and regulations, maybe payment card industry or PCI compliance, or perhaps ISO 9000. As a result, the company started to store data not just for their own internal archival needs, but also for compliance purposes for independent audits. Finally, looking to the future, the CEO recognized that, hey, we should care about our business continuity, and directed his IT staff to create a disaster recovery plan. The IT department purchases tape backup solution, contracts with a third party to store the tapes off-site, and so now that data is being archived to tape and shipped to a secure off-site location in case the worst possible scenarios happen. And all seems good. Our data is securely stored, we can handle our compliance audits, and we can recover our data from our tape backups in the case of a disaster. Except, company now has a growing set of challenges. What are some of these challenges? So the company has to manage the physical hosting in a data center. And even with smart hands, there's still times the company has to send their IT staff down to the data center for more sophisticated troubleshooting and problems. What's more, that data center acts as a single point of failure. Thinking through a worst case scenario, let's presume that data center is not available. Maybe it catches on literal fire, and your racks and data are at best smoke damaged and at worst destroyed. In that scenario, your disaster recovery plan starts with trying to have your tape sent back to you from the offsite storage, with an obviously very large time to recovery. Speaking of the infrastructure, it's not just the availability or disaster recovery issues we have to be concerned with. We have capital expenditure for the servers, for libraries and tapes. As the company stores more data, this capital expenditure is going to recur again. On top of that, there's the issues with purchasing new tapes, libraries, handling obsolescence issues when tape generations change. Of course, we have to staff this with smart and dedicated IT staff. So we're spending money and resources on things that are really not germane to the mission of the company, the things that make that company valuable. There's the cost and management of the logistics of the offsite storage and transporting the backups. Most importantly, there's the opportunity cost. That IT staff, very smart individuals, had plenty of other things to be working on other than the physical infrastructure and managing the logistics of offsite backups. And that opportunity cost is going to continue to grow right along with the ever-increasing need of that business to archive more data. Now, the good news is, these are challenges that Amazon S3 Glacier can help solve. Amazon Web Services is a leader in cloud archival storage. We are one of the first vendors to offer a branded solution in the public cloud cold storage market with the release of Amazon Glacier in 2012. We haven't been idle. We continue to innovate in this space, as evidenced by our release of the Amazon S3 Glacier Deep Archive Storage class in 2019. We're happy to say that the pace of our innovation is accelerating this year. When you're considering where to store your data in Amazon S3 Glacier, you now have 6 different storage classes designed for the lowest cost for specific use cases and data access patterns. We're happy to say that new this year, S3 intelligent tiering now has expanded capabilities to include an automatic archival option. All Amazon S3 storage classes from S3 Standard to S3 Glacier Deep Archive are designed to provide 11 nines of durability of objects over a given year. In addition, all storage classes, with the exception of S3 One Zone IA, are designed to sustain data in the event of an entire S3 availability zone loss. Okay, so this is a little bit of an aside, but if we think back to our hypothetical customer scenario where they had built out their storage infrastructure in a single data center, by adopting Amazon S3 and using S3 Standard, S3 Standard IA, S3 Intelligent Tiering, S3 Glacier, or S3 Glacier Deep Archive, they automatically gain redundant storage of their data on multiple devices across a minimum of 3 availability zones in an Amazon S3 region. That's super important. Issues can happen with any physical infrastructure. And so for any business looking to store large amounts of data, you want to ensure that you have that redundancy built into your data storage plan. By choosing any one of the 5 storage classes I just mentioned, you automatically get that redundancy. Specifically, though, let's talk a little bit more about the archival use case, because that's really what we're focusing on today. And Amazon S3 has 3 different storage classes that fit well for archival purposes. S3 Glacier Deep Archive, which is perfect for truly cold data. S3 Glacier, which is great for our active archive use cases with retrieval times measured in minutes to hours. And again, as I said, new this year, S3 Intelligent Tiering with its new automatic archival option. And that's really great for customers whose pattern of data access is more unpredictable. For this session on data archiving, we're going to focus on the storage classes most useful for storing large amounts of data for very long periods of time, starting with our newest option, S3 Intelligent Tiering with automatic archival. All right, so if you're not familiar with S3 Intelligent Tiering, this storage technology was released in 2018. And it's the only cloud storage class that automatically delivers cost savings by dynamically moving objects between now 4 access tiers based on changing access patterns. The great thing about S3 Intelligent Tiering has always been the lack of operational overhead, lifecycle fees, or restore fees, while still maintaining that high availability and durability that you expect from Amazon S3. So up until this year, customers with datasets with high performance requirements using S3 Intelligent Tiering automatically took advantage of millisecond latency and high throughput performance with a frequent access tier priced the same as S3 Standard, and an infrequent access tier priced the same as S3 Standard Infrequent Access. And that's all still remains the same. But new this year, customers can also choose to activate automatic data archiving to get the lowest storage costs in the cloud when data is not accessed for long periods of time. Under this new automatic archiving, customers have the option to save even more on their storage costs, up to 95%, by activating a new archive access tier priced the same as S3 Glacier, and a new deep archive access tier priced the same as Glacier Deep Archive. Because your data is now being tiered into storage classes designed for archival access, your access times, however, are going to change from milliseconds all the way up to minutes or hours. All right, so let's think about this a little bit more in action. When an object is stored in S3 Intelligent Tiering, it's first stored in the frequent access tier. This is analogous to S3 Standard with the same high throughput performance. Now, if you don't access your object for 30 days, you can start saving some money because that object is going to be moved into an infrequent access tier, which is priced the same as S3 Standard Infrequent Access. Now, for many customers, that's where the tiering down stops. And that's where it traditionally stopped up until this year, unless you've opted into archival. If you've opted into archival, at that point, if you still haven't accessed your object, then after 60 days, your object is moved into the archive access tier. This is key. It's important to note that at this point, accessing your object is going to switch from requiring a synchronous get to an asynchronous restore, followed by a synchronous get. And as you might infer, that's due to the changing time it takes to access your object, going from milliseconds to now minutes or hours. Finally, if you haven't accessed your object for 90 days, it's moved into the deep archive access tier. Now, the beauty of this is all of this is taken care of for you. Rather than having to worry about lifecycle policies or restore fees, you instead pay a predictable monthly monitoring and automation fee of 1/4 cent per 1,000 objects. We're going to come back to this last point a little bit later in this presentation. I'm going to reiterate it, though, because it's super important for customers with large data sets. When using S3 intelligenting with archival support, while you're going to pay that fraction of a penny per thousand objects, so it's a little bit extra per month in a monthly monitoring and storage and automation fee, there is no fee for having the data move between the storage access tiers or for restoring data from a colder access tier to a warmer tier. We're going to see a little bit later how that can benefit some customer use cases. So let's come back to our hypothetical company and look at how their use cases fit into the family of S3 storage classes that are most applicable for archiving large data sets. So this customer that we talked about had a data lake, heterogeneous data with a variety of business use cases driving the access of that data. Now, this is a great option for S3 intelligent tiering with automatic archival. The access pattern of the data is really not always well known. The engineering department might need some of their data frequently, code repositories or design documents for their most active areas of innovation. While the finance department may have financial records stretching all the way back to the inception of the company, and they may only need to access maybe last year frequently, while the older records are only pulled up during audits. Using S3 intelligent tiering with automatic archiving, our hypothetical company can store that data in a set it and forget it mode of operation, allowing them to optimize storage costs when access patterns change without any analysis, operational overhead, or restore fees. Second, customer had a business continuity plan, and they're using their archives in case some disaster strikes their business or their infrastructure. Now, this is a little bit of an interesting one because both S3 Glacier and S3 Glacier Deep Archive can be attractive here. The important distinction is that in a true disaster recovery scenario, some of your data, such as the backup for your website or for maybe your email server, is probably more important than the backup of pictures of your company picnic from 8 years ago. So not all data is exactly the same in a disaster recovery scenario. In the former case, S3 Glacier is a great storage class because it supports faster retrievals than S3 Glacier Deep Archive, while still having significantly lower storage costs than S3 Standard infrequent access. Likewise, you still care about all of your company's data, even your company picnic pictures. And for that, S3 Glacier Deep Archive might be appropriate. You want the data to last forever, but you don't need to access it often or quickly. And so you may end up using a combination of both storage classes for your disaster recovery use case. Finally, the customer had compliance needs, potentially on very old data sets. Here, using S3 Glacier Deep Archive can make a lot of sense. Accessing the data for compliance is predictable, rarely occurring activity that only needs selected data sets over very specific time periods. And because that access pattern is rare and well-defined, using S3 Glacier Deep Archive for optimal storage costs is a perfect fit. All right, so let's dive deep a little bit further into the differences between S3 Glacier and S3 Glacier Deep Archive, or their equivalents in S3 intelligent tiering. The principal difference, other than price, is the time it takes to restore an object. In particular, expedited retrievals are not available as an option for S3 Glacier Deep Archive. The fastest you will get your data back from S3 Glacier Deep Archive is typically within 12 hours. Now, for truly cold archival use cases, that's just fine. Again, considering the case of a compliance audit where you may have plenty of advance notice of the audit, a 12 to 48 hour retrieval time is perfectly reasonable because you're more concerned about the storage costs associated with storing the data for many years. On the other hand, your most critical backups, the most important data to your company, you may need a lot faster. In those cases, using S3 Glacier is a much better use case. You're generally looking at restore times measured in 3 to 5 hours for standard restores as compared with Glacier Deep Archive's 12 hours. And of course, with expedited retrievals, you have the ability to pull your most critical data back typically within 1 to 5 minutes. So let's talk a little bit about the considerations that companies should think about that may impact their data use cases when they're archiving into either S3 Glacier or S3 Glacier Deep Archive, or the equivalents in S3 intelligent tiering. Now, there's 5 key characteristics of your data you should consider to minimize cost and have the best possible performance. First, object lifetime. It's always important to remember that early delete fees will apply if you delete your data within 90 days of transitioning to S3 Glacier or 180 days to S3 Glacier Deep Archive. Second, the number of objects. When lifecycling objects for S3 Glacier, S3 Glacier Deep Archive, there is a charge of 5 cents per 1,000 requests and an overhead of 40 kilobytes per object stored. So minimizing the number of objects being archived will therefore help you save money. One way of doing that is to manage the third characteristic, object size. Bundling a large number of smaller objects together into fewer but larger objects using zip or tar is a mechanism to archive fewer objects of larger but compressed size. In general, it's a good thing to keep in mind, storing fewer but larger objects is going to result in overall lower costs. Fourth, retrieval frequency. S3 Glacier Deep Archive is designed for retrieving objects once or twice a year and within 12 to 48 hours. S3 Glacier, on the other hand, supports a more robust set of retrieval times, but with corresponding higher costs. And finally, retrieval ordering. S3 Glacier is designed for 35 random restores per petabyte stored per day. What this means is that when you're looking to restore a large number of objects, you want to minimize this notion of randomness. We're going to come back to this particular consideration as it's a little nuanced, but it's important when planning your restorations of large amounts of data. Now let's look at the implication of object size and number of objects on costs. Here's where I remind you of what I said earlier about S3 intelligent tiering. If you don't want to have to manage or think about lifecycle and retrieval fees, you can use S3 intelligent tiering with automatic archival enabled. Using that storage class, all of the lifecycle fees and standard bulk retrieval fees are waived, and you instead pay a small flat per object monthly management fee. But let's assume that your access patterns are well defined and you want to use the S3 Glacier or S3 Glacier Deep Archive storage class directly. To illustrate the effect of object size and number of objects on costs, let's consider storing 1 petabyte of data in S3 Glacier or S3 Glacier Deep Archive. You can see that as my average object size gets larger from 1 megabyte to 1 terabyte, my monthly storage costs only change a little bit. Although there is some fluctuation as S3 Glacier and S3 Glacier Deep Archive has a 40 kilobyte per object overhead that does add a little bit to the cost per object. Storing 1 megabyte in S3 Glacier will cost you $4,160 per month, while storing 1 terabyte in the same storage class is effectively $4,000. Likewise, you'll save more money by using S3 Glacier Deep Archive, but still pay a small amount more per month when your object size is smaller. Now, what you can note, however, is that the lifecycle costs and restore costs are significantly less expensive, as both the object size and the amount of time I'm willing to wait to restore my object increases. So for standard retrievals, pulling back 1 petabyte from S3 Glacier will range from $60,400 for 1 megabyte objects to $10,000.05 for 1 terabyte objects. By increasing the average object size from 1 megabyte to 1 gigabyte, we can achieve nearly a 6x cost savings. Interestingly, at that point, the cost savings you get from increasing the object size from 1 gigabyte to 1 terabyte decreases significantly, as the number of requests needed to restore the objects is already an order of magnitude lower. Now, it's actually more expensive to perform standard retrievals when your objects are in S3 Glacier Deep Archive. At the standard tier, it ranges from $120,800 for 1 megabyte, $20,100.80 for 1 gigabyte, and $20,000.10 for 1 terabyte. It's a huge range. Of course, the faster the retrieval, the more expensive it is to retrieve a full petabyte of data. But here, we can also see that the archival storage class with more expensive monthly storage costs, S3 Glacier, has cheaper restores than S3 Glacier Deep Archive at the standard tier. Now you can trade off speed for price. By issuing requests at the bulk tier, the price for S3 Glacier and S3 Glacier Deep Archive works out to be the same. Restoring data at the bulk tier for objects with an average size of 1 megabyte is $27,600, going down to, for 1 terabyte, at $2,500.03. So the final lever available to control costs at the bulk tier is object size. Restoring larger objects will save you nearly $25,000, moving from 1 megabyte to 1 terabyte. Now let's look at our final consideration for archiving large data sets, the notion of random restores and its impact on our throughput. It's always helpful to think of the S3 Glacier and S3 Glacier Deep Archive storage classes a bit like a freight train. Once S3 Glacier starts restoring lots of data, it can move a lot of data with very high throughput. However, anytime the objects being restored are random, the train never really gets moving and you become limited to 35 restores per petabyte per day. Now, if you're looking to restore thousands or millions of objects, getting limited to 35 restores is clearly going to be a bit of restriction on getting your workload done. So to maximize the number of objects you can restore in a given day, you want to minimize this notion of randomness. Generally, what that means is issue the restores for your objects in the same order that they were placed into S3 Glacier or S3 Glacier Deep Archive. So here we can see we have 5 objects in our bucket that were placed into S3 Glacier. We issue 5 restore requests in the same order that these objects were placed into Glacier. And because we issue these requests in that same order, we don't have any restrictions placed on the restores. This is what we call a sequentially ordered restore, and it doesn't become restricted by the 35 restores per petabyte stored per day. And you can issue thousands to millions of restores, and Glacier will happily restore that data within the expected 2 retrieval time. So what does a random restore look like? Well, we can see that a random ordering of restore requests can also simply be issuing restore requests in a completely different order than the order that the objects were placed into S3 Glacier or S3 Glacier Deep Archive. We have 5 objects that were placed in. However, we issue the first restore request for object number 3. We issue the second restore request for object number 4. We issue the third one for object number 2, and etc. Now, because these restores are not well ordered with the way the objects were placed into S3 Glacier or S3 Glacier Deep Archive, they classify as random restores. And as such, while we will attempt to restore those objects as fast as possible, the customer issuing those requests can be subject to 35 restores per petabyte per day. Now, obviously, for some archival use cases, such as compliance, where you may need to only pull back a few objects for audit purposes, this isn't the large consideration. On the other hand, when you're performing disaster recovery, where you need to pull back large amounts of data, it can be very important to remember this consideration. Thinking back to our hypothetical company, they may have stored everything from critical infrastructure, such as the backups for their website or snapshots of their production database, to less critical data, such as memos or documents or their company picnic pictures. Issuing restores for the most critical backups first, and making sure that those restore requests are done in the order that the data was put into Glacier helps to maximize the number of restores that can be performed, and likewise, how fast Glacier can give you your data back in time-sensitive scenarios. Let's recap our best practices. First, have an archival plan that fits your large data use case. Once you understand how you need to use your archival data, map that to the most appropriate Amazon S3 storage class: S3 Intelligent Tiering with Archiving, S3 Glacier, and S3 Glacier Deep Archive. Second, know how you will access your data. Use S3 Intelligent Tiering with Archiving if you don't know the access pattern of your data, or if you don't want to deal with lifecycle or retrieval fees and would prefer instead to pay a small flat management fee. Use S3 Glacier if your use case has access patterns that include emergency scenarios, where you need a small subset of your data back in minutes. Lastly, use S3 Glacier Deep Archive if your data is truly cold and the accesses are predictable and infrequent. Third, plan ahead for asynchronous operations. In particular, this is important for the new S3 Intelligent Tiering with Archiving. Your access pattern will change from synchronous gets to an asynchronous restore followed by an asynchronous get. Plan ahead for how that may change your application when you're storing data in S3. 4, have a cost plan for the entire lifecycle of your data. Certainly, archival storage classes will help you optimize your cost, but don't forget to take into account the interplay of object size and the number of objects on retrieval and lifecycle costs. And of course, if you want AWS to handle that for you, use S3 Intelligent Tiering with archival support. 5th, optimize your objects for your archival plan. If you have lots of small objects and your access pattern will require you to restore all of your objects, consider bundling them together with compression to minimize the 40 kilobyte overhead, lifecycle, and restore fees. Finally, when restoring large number of objects, minimize randomness by restoring objects in the order that they were placed into S3 Glacier or S3 Glacier Deep Archive storage classes. This will improve the overall throughput available to you when you're performing restores of millions of objects. It's been my pleasure to share best practices for archiving large data sets with AWS with you today. For additional information on the technologies discussed today, or to learn more about how customers have archived their data while optimizing costs using Amazon S3, please check out the resources on this slide. And thank you for being a customer of Amazon S3 Glacier.